Well, now we're doing section 4-2, and an architectural drawing of an outside deck is 3.5 inches wide by 10 7/8 inches long. Let me point this out. 3.5 inches equals 3.5 inches. We can, when you convert that to a decimal, and 10 7/8 inches, when you convert 7/8 to a decimal, you wind up with 10.875 inches. Okay, now we can go back to work. So if the deck will actually be 14 feet wide, calculate the following: the actual length of the deck. Okay, so this is number 1A, and we're going to have the actual length, L over, and what value represents the L in the model or the drawing? It's 10 7/8, which is 10 and 0.875 equals, and the actual width is 14 feet. And by the way, this is inches here, and this is feet, and this is going to be over 3.5 inches. Now we'll multiply both sides. We need to isolate L, so we'll multiply both sides by 10.875 inches. 10.875 inches. Now the inches here divide out, and all of that divides out, and we're left with L equals, and this is going to be in feet. Those are the only units left standing. 14 times 10.875 over 3.5, and that's feet. And so L equals 43, when you run this through a calculator, 43.5 feet. Okay, and now they also want us to find the scale factor. So let's do that. And to get the scale factor, all we have to do is take, well, we're given the two values for width, and we'll put 3.5 inches. This is B, and the scale factor is 3.5 inches. Divide by 14 feet. This is a width, this is a width. We'll multiply by a unit multiplier such that the units divide out, and when we do that, we'll have the scale factor. So there's 12 inches in a foot. Now the feet divide out here, the inches divide out there, and when we resolve that, we get 1 over 48. So the scale factor is 1 over 48, and we're done with that. Now let's do number 2. A pair of belted pulleys have diameters of 20 inches and 16 inches, respectively. If the larger pulley turns at 2,000 RPM, how fast will the smaller pulley turn? Well, the smaller pulley is going to turn faster than the larger pulley. And so the larger pulley, and let's see, we'll just call this A. That's the RPMs of the smaller pulley, and the larger pulley pulls at 2,000 RPM. And now, this is an inverse situation. The larger pulley will also have fewer revolutions than the smaller pulley. So we're going to exchange the corresponding material of 20 inches in diameter and 16 inches diameter. We're going to assign the smaller diameter to the denominator of associated with the 2000 RPM, and the larger diameter is going to be associated with the A, which is the RPMs of the smaller pulley. Now we'll multiply both sides by 20 inches and we'll have A isolated, 20 inches. These divide out and we get A equals, now inches divide out, and 4 goes into 25 times and 4 goes into 16 4 times. 4 goes into 2,500 times, and 500 times 5 is 2,000, 2,500 RPMs. And those are the RPMs of the smaller pulley, and we're done.